so much.
Number 6.
Okay.
So they tell you that P equals 0.75,
Okay, we'll do it. You
and
guys take care and stay inside.
the N is
Okay.
N is 5. So let's write that down. Probability of success, probability of getting some probability that someone is wearing a seatbelt is 0.75, and you're going to do 5 cars at a time. Now, one way to simulate this is with the calculator. So you just use math and then arrow over to PRB and rand int 5, and you do 1. I'm sorry. Yeah, 1, comma 100, comma 5. So just to give you 5 numbers between 1 and 100. You don't worry about repeats. So the 5, this is the 5 cars. This represents 5 cars going by. And 1 to 100 represents the probability that the drivers have seatbelts on or not. So here's a 95 that's not a seatbelt, 91 that's not a seatbelt, and here's 3 that have seatbelts. You hit enter again. So that's the end of one trial. So the response variable is the number of drivers out of 5 wearing the seatbelt. And so here's another trial. Seatbelt, 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 not a seatbelt, seatbelt. So the response variable here, I'd write down a 4. So here I did 30 trials, just hitting enter, over and over again, and then recording how many out of the 5 were between 1 and 75. Okay, since I did it 1, comma 100, 76 to 100 represents not having a seatbelt, and 1 to 75 represents having a seatbelt. So I added them all up. Okay, so there was a total of 113 drivers. So for each trial I averaged 3.7 drivers out of 5 that had their seatbelts on. Now from this table I take the following probability. So that's the simulation, and I ran 30 trials. What are the probabilities there are no belted drivers? Well, I had no results that were 0 out of 30. So according to my simulations, the probability that B equals 0 is 0. Hold on a second. And, okay, it's the probability of 1. I had no answers that were 1s. So the probability that the belted drivers equals 1 out of 5 is 0. And 2 equals 0. Now, I only started getting responses with 3. 13 out of 30. So I had 3s. I had 13 3s. I had 11 4s and 6 5s. Now, how does this experimental results compare to the theoretical results? Well, here's the theoretical results. So what are the events that can happen? It's a discrete random variable. I can get 0, 1, 2, 3, 4, or 5. So what's the probability of getting none? That would be 1/4 to the 5th, the complement. So in other words, 1 minus 0.75 to the 5th. That probability is very low, 0.0009. So it makes sense that out of 30 trials this wouldn't happen. Now, the probability of 1 out of 5, that's 5 choose 1. I'm using binary probability here. 0.75 to the first times 0.25 to the fourth, 0.0146. Again, that's very low, and so it's unlikely that would happen in 30 trials. Now 2 is 5 choose 2, 0.75 squared times 0.25 cubed. That's 0.0879. Now let's just review how I'm doing this for a second. So that's second vars and normal CDF 2, and then I would put in n, which is 5, and then the probability of success, 0.75, and then how many successes are we looking for? So the first probability was 0. I just used the complement to this, but let's say we were using normal CDF, I'm sorry, not normal CDF, binom CDF. Second vars, binom CDF. Okay, so n, comma, 0.75, comma, 0. So here's the first probability that I get 0 out of 5. Okay, and you can see that's 0.0009. You could call it, or you could call it 0.001. Okay, now to do the next one, 1 out of 5, binom CDF, and I just change the 0 to a 1, and I get 0.0146. 0.75. I must have, this is a typographical error. I wrote this down wrong. I know this is what I did. Anyway, this is 0156. Okay. And the next one, second, enter, 2. Okay, I just forgot that I was doing just individual probabilities. So that would be second and vars and binom PDF. I was doing binom CDF, binom PDF, which is what I was doing when I put together this table. So binom PDF is 5, comma, 0.75, comma, 1. So let's do this. Okay, that's 0.01. That's what I had before. Just forgot that that's what I was doing, 0.0146. Okay, and then let's do the next one. Let's do 2. PDF just does one individual probability. CDF adds up probabilities starting at 0 and then going forward. That's why I was getting these different numbers. So there's 0.0879 and so on to fill out the rest of the table. So how do these compare? Well, my experimental probability for 0 is pretty close to the theoretical probability of 0.0009. My experimental probability for 1 equaling 0, there's 0 chance of getting it, is also fairly close to the theoretical probability. Now for 2, there's almost a 9% chance of getting 2. So, it's out of 30 trials, it's not, it's quite possible that I wouldn't get a 2. But a 9% chance of 2 occurring, 2 should definitely occur by chance. Now 3, 0.2637. Okay, now my experimental probability is 13 out of 30, so that's certainly bigger than 0.26. It's a little, it's greater than a third, so it's quite a bit bigger. On the other hand, 4, which is almost 40%, is smaller, and 6 out of 30, which is 1/5 is 20%, that's also smaller. Because for 5, the theoretical probability was 0.2373. So, anyway, that's it for 6. I think that's the last. Yeah.